Hello, my name is Kurt Kumlin, Senior Loss Control Consultant with Integrated Loss Control. We're here today to discuss hazard communication and our right to know about hazards in our workplace. First, let's consider risk, and we can look at it as a risk window. How open is our window? We are in control by the decisions that we make. When we make decisions, we need to understand that there are trade-offs. So when we make a decision to engage in a behavior, do you know what you're about to trade off? Have you considered that? So from the safety perspective, you want to make an informed decision and minimize that risk by understanding the risks that you're about to take and how to protect yourself from them. Before I get started on hazard communication, let me back up to discuss the company administrative or AWARE program. Minnesota OSHA requires a written safety program known as AWARE, an acronym that stands for a Workplace Accident and Injury Reduction Program. There are key components required by this program, and they include establishing clearly stated goals and objectives. The program must be in writing, and in that program it needs to describe the responsibilities of all employees, the methods used to identify and control hazards, how the program will be communicated to employees, how accident investigation will be conducted, and how corrective actions will be implemented, how safe work practices and rules will be enforced. The program requires an annual documented review of the goals to determine if objectives have been met. We can find this program in our safety policies and procedures. Manning Transfer utilizes Integrated Loss Control's eSystem. This is a computer-based systems approach to managing the loss control programs. We can see the introductory page where we would select Health and Safety tab, and in here it takes us to our filing cabinet, which it shows us where the Health and Safety manual can be found. From here, the cabinet will open and present us with some file folders. Here we would select what program we are interested in viewing, in this case the Administrative Health and Safety or the AWARE program. So our objectives for today are to understand our rights relative to the safety program and the concept of right to know. We want to know what toxic substances are in our workplace, what harmful physical agents present themselves to us, and what infectious agents we may be exposed to. We want to understand what their hazards are, and we want to understand how to protect ourselves from those hazards, and also understand sources of information where we can obtain information about those hazards and controls from labeling or other sources like the safety data sheets. So your rights and right to know. These include your right to know about hazards of your work, whether or not you're exposed to hazardous substances, harmful physical agents like heat, noise, or radiation, or infectious or contagious agents like human blood or bodily fluids. You also have a right to know what degree of that exposure there is, what the hazards are related to those exposures to those agents, and methods to protect yourself from them. With safety interventions, we consider a hierarchy of controls. These are ranked from most effective to least effective. First being elimination, where we physically remove the hazard or the task from our process to begin with. Next, we might use substitution, where we would place a hazard with a less harmful substance or a less harmful operation. Then we may employ engineering controls, where we isolate people from the hazards with things like barriers or shields. We can use administrative controls if engineering controls are ineffective, where we teach people how to work and operate around those hazards and protect themselves when they are engaged in those tasks. Our last control is the use of personal protective equipment. It is the least desirable control, as it is probably the least effective means of protecting us from hazards. Now we'll explore hazard communication labeling. All hazardous chemicals must be stored in properly labeled containers, whether they are in the container that you receive the chemical in, or if they're secondary containers that we dispense chemicals into so we can use them in the workplace. All these labels must include the product name, hazard warnings, and GSH elements, or elements required by the Global Harmonized System programs. You never want to remove, alter, or deface any chemical container label unless the container no longer contains the substance on the label or has been triple rinsed, Then you would affix a new label for the substance before use. Make sure that you label or report all unlabeled containers to your supervisor. There are numerous types of chemical labels, and it's important that you understand all of them. Perhaps most common is the NFPA symbol. The blue diamond represents the health hazard of the chemical. Within that diamond you'll find a number between 0 and 4. 0 indicates no hazard, whereas a 4 indicates a chemical which may be deadly. The red diamond represents the flammability hazard of the chemical. Again, you'll find a number between 0 and 4. The yellow diamond represents the stability or reactivity hazards of the chemical. And the bottom diamond will almost always be blank, but in some cases may communicate any special hazards. Another common means of labeling chemicals is the HMIS symbol, or Hazardous Material Information System. The number and color codes are identical to the NFPA symbol we just reviewed, but at the bottom is a letter code indicating the type or types of PPE which must be worn while handling the chemical. Always check with your other resources like the safety data sheets, other labels, any posters, any manufacturer websites, or other sources that may provide that information to make sure that we determine what PPE we should be using. Another common type of container labeling is the so-called signal words system. Signal words include danger and warning. These signs will usually describe the nature of the hazards and the steps you need to take to remain safe. You should also remember that the different words will indicate different levels of hazards. For example, the word danger indicates the immediate danger or hazard, and that special precautions are required. The word warning is used to indicate intermediate hazards, which, while capable of causing injury, are less likely to do so. Another word that is still used is caution. This word is used to warn employees against unsafe actions or behaviors. The two words danger and warning will continue to be used going forward. Make a note that if a substance is a mixture, anything with a danger classification will classify that mixture as danger. We have discussed HMIS and NFPA labeling, where we've ranked our hazards from 0 for minimal to 4 for severe. Under the new globally harmonized system, international companies may have reversed this ranking from 1 indicating a severe hazard to 5 being a minimal hazard. However, we can continue to use that hazard ranking system as before. Employers may continue to use the rating system such as NFPA diamonds and HMIS requirements for workplace labels as long as they are consistent with the requirements of the Hazard Communication Standard and the employees have immediate access to the specific hazard information. An employer using the diamond or HMIS label must provide training to ensure that employees are fully aware of the hazards of the chemicals used. Other examples in the workplace of hazard communication include label systems with signs, placards, process sheets, batch tickets, operating procedures, or other such written material to identify the hazardous chemicals. Employers may use additional instructional symbols that aren't included with the hazard communication pictograms, such as a person with goggles that might denote that goggles must be worn when handling a given chemical. Here we have an example from your workplace, non-chlorinated brake cleaner, that uses the danger hazard warning wording, which indicates harmful or fatal effects if it's swallowed, extreme flammability, and that the contents are under pressure and can cause eye injuries. Here we have an example from a compressed gas oxygen bottle from cutting torch operations, which indicates it's oxygen, which is an oxidizer, which can accelerate flames, and that it is also a compressed gas. Here's a picture which shows the location of flammable and combustible liquids that are stored in a safety cabinet. Here we can see a label that's ready to go from the storage cabinet. This is an epoxy part B, one of the agents in the epoxy mixture, the hardener in this case, and it shows our hazardous pictograms. It shows the exclamation point. It indicates exceptional hazards. It shows health hazard pictogram, and it shows it a corrosive pictogram. It also indicates that this product is considered hazardous under OSHA's Hazard Communication Standard. I've discussed Globally Harmonized System, or GHS, so what is that? The GHS program was implemented to target audiences that include workers, consumers, transport workers, and emergency responders on an international basis, so that labeling practices and safety data sheets can be published and printed in a standardized format. This provides the underlying infrastructure for establishing these national comprehensive chemical safety programs. Chemical labeling from the chemical manufacturer must have the following information on the label: the product identifier, the signal word, hazard statements, pictograms, and precautionary statements. All chemical distributors must also follow these guidelines. OSHA will allow for other types of labels as long as they convey the same information. It's assumed that it will become best practice to label all chemicals following the guidelines within the Global Harmonized System, and labeling will follow the sample label you see here. OSHA does allow continuing to use other labeling methods, as we've discussed, the NFPA and the HMIS labels, as long as the required information is readily available to the employees in those various formats, safety data sheets, posters, pictograms, and provides the employers with physical hazards of the hazardous chemical. So we'll review some pictograms to identify their meaning. Here we have the pictogram that indicates a health hazard. This pictogram is used to represent things like carcinogens, reproductive toxicity, respirator sensitizers, target organ toxicity, and aspiration toxicity. The flame is used to represent flammables, pyrophorics, self-heating type chemicals, emission of flammable gases, any self-reactive chemicals, and also organic peroxides. Here we see a flame over a circle. This pictogram is to identify chemicals which have the oxidizer hazard. Oxidizers or oxygen, as we know, will accelerate flammability. Here we have the gas cylinder pictogram, which indicates gases under pressure. This pictogram is used to identify chemicals that are corrosive and can cause burns, whether they can cause eye damage, and if they can be corrosive to metals, things like acids as well. Here we have the exploding bomb, which can indicate explosives, self-reactive chemicals, and also organic peroxide when they're in a concentration high enough to detonate. Here we have the pictogram that uses an exclamation mark, as we saw in an earlier example. This pictogram will identify chemicals with particularly hazardous characteristics like irritation, skin sensitizer, acute toxicity, narcotic effects, respiratory tract effects, and whether they're hazardous to the ozone layer, which is a non-mandatory type of categorization. The symbol will appear on chemicals with less severe toxicity. For more severe toxicity, we'll see the skull, such as this pictogram, which identifies chemicals with the acute toxicity characteristics. Here we see a non-OSHA, non-mandatory environmental pictogram, in this case indicating aquatic toxicity. Now let's talk about safety data sheets. Here, your safety data sheets can be found in this book, the SDS Manual for Manning Transfer Incorporated. Safety data sheets are written in a standard format with 16 sections. They contain the important information about the hazardous substances that they address. You have a right to review and photocopy these sheets. Safety data sheets can also be kept on a computer system, but employees must ensure that the safety data sheets are readily accessible to employees for all hazardous chemicals in the workplace. Employers can keep them in a binder or on computers as long as employees have immediate access to the information without leaving your work area when you need it. And a backup is available for rapid access to the safety data sheet in case of a power outage or other. Since your company uses Integrated Loss Control Safety Data Sheet Inventory Manager, the safety data sheets may be placed on there. If you were to go to this screen on the system, you would see instructions for using this spreadsheet. Here we can see an example of a safety data sheet entered on the chemical inventory spreadsheet which you would see if you were to use the Integrated Loss Control SDS management program. There are 16 sections of the safety data sheet. The employee should make sure that the employer has a copy of any new safety data sheets that come in. Employers must provide these safety data sheets for their employees' review of all hazardous substances that they may be exposed to during their course of the work. Some of the key parts of these safety data sheets include the identification of the substance or mixture and the supplier, the hazard identification criteria, composition or information on the ingredients that make up this mixture, first aid measures that can be taken, firefighting measures, accidental release measures, how to handle and store it, what personal protective equipment might be used, some of the physical and chemical properties, the stability and reactivity information, and the toxicological information. Some of the non-mandatory information might be related to ecology, disposal, transport, and regulation of the chemical. One important piece of information found on the safety data sheet of a product is the permissible exposure limit, or PEL. PELs are considered safe exposure levels and are set by OSHA, not the manufacturer. A product with a higher PEL means that it generates a lower hazard to the worker. There are other measurements like threshold limit values, or TLVs, recommended exposure limits, RELs, and then you may find a workplace environmental exposure limit, or WEEL, are all different opinions of safe exposure levels. Exposure means to be subjected to an action, influence, or condition that may result in an injury. You are the first method to determine an exposure. The body's 5 senses can detect an exposure and should give you warning signs of a change in the environment. Your employer can conduct regular industrial hygiene monitoring to monitor levels that you may be exposed to. Another tool your employer uses are the safety data sheets that are available for you to review. When we're exposed, we're usually exposed through different routes of exposure, and these can include inhalation, or breathing something in, absorption, which usually occurs when we come in contact that soaks through the skin, ingestion, where we might eat something, and contact through the skin and eyes. Think of your skin as your last and final layer of personal protective equipment, so take good care of it. Remember to wash hands frequently, especially prior to eating or drinking. Keep your skin clean and dry as much as possible, and take precautions against puncturing. Now let's talk about biohazards. Biohazards are exposures to things like pathogens and viral infections. Minnesota has a rule, 5206.0700, which covers biohazards. It discusses the epidemiology and symptoms, which include at-risk employee groups. It addresses appropriate methods for recognizing tasks and other activities that can involve exposure to infectious agents. It addresses a chain of infection or infectious disease processes. It addresses having a written exposure control program. And it talks about use and limitations of methods of control, such as engineering controls, work practices, personal protective equipment, and housekeeping or sanitation. The training includes the basis for selection of personal protective equipment, like the type, how to use it, where it's located and stored, how to remove it, handling it, how it's decontaminated, and how it may be disposed of. It also talks about procedures to follow for an exposure incident, what happens when you are exposed, including methods of reporting, information about post-exposure evaluations, and follow-up. The training also needs to include any reference materials necessary for that exposure. When we talk about biological agents and biohazards, we're generally talking about 5 different groups of agents. These include viral infections like coronavirus, SARS, hepatitis B, hepatitis C, or HIV. Bacterial agents like E. coli or Salmonella. Fungal agents like Histoplasma C. Parasitic agents like amoebas and Giardia, and others. There are no established for biological agent exposures such as OSHA PELs or threshold limit values. The state of Minnesota tracks biological agents, or agents they determine need to be considered biological agents, and that list is updated every 2 years. So where do we find our bloodborne pathogens, pandemic programs, and exposure control plan? We find them either in our manuals or in that electronic filing system that is kept on a computer. All employees should be able to review this plan at any time during their work shifts by contacting a direct supervisor or department head. If it's requested, the safety officer will provide an employee with a copy of the exposure control plan, free of charge and within 15 days of the request. The safety director is responsible for reviewing and updating that exposure control plan annually, or more frequently if it's necessary to reflect any new or modified tasks or procedures that affect occupational exposure, and to reflect new or revised employee positions with occupational exposure. Here's an example of the page you would find on the electronic computer-based system. You can see where bloodborne pathogen exposure control plan is highlighted, the hazard communication right to know program, and you can also see where pandemic is highlighted. From this link you would find this pandemic program description here. This gray box describes everything that is contained in that program. So who are the affected employees? They're all employees that are potentially exposed to blood or other potentially infectious materials from cleaning or disinfecting surfaces and equipment after accidents, routine cleaning and janitorial work, or providing first aid treatment or transportation to injured employees, as a few examples. There may be COVID-19 exposure from community exposure and work exposure, from close contact with other people or co-workers, clients, or visitors to the facility. For COVID-19 and for bloodborne pathogens, all employees who could be reasonably anticipated to face contact with respiratory droplets, viral agents, blood, or other potentially infectious materials as a result of the job duties are considered affected employees, if this exposure is in a sufficient quantity to cause diseases. These pathogens can spread through several paths, including direct contact, indirect contact with another person, a respiratory transmission, or through vector-borne transmissions like ticks or mosquitoes or other insects. It's important that you contact a doctor or supervisor if you should begin to feel ill. Bloodborne pathogens are disease-causing organisms which may be found in human blood or other potentially infectious bodily fluids. All employees are potentially exposed to these pathogens when they clean or disinfect surfaces and equipment after accidents, much like our earlier exposures, during routine cleaning and janitorial work, when providing first aid or medical treatment or transportation of an injured employee, and other tasks. One of the most important types of bloodborne pathogen is the hepatitis B virus. Hepatitis B is a virus that attacks the liver and leaves the body unable to detoxify or cleanse the blood supply of contaminants. Hep B often will lead to a condition called cirrhosis, which is a hardening of the liver, resulting in decreased liver function. Hepatitis B will sometimes lead to liver cancer. There's an average of approximately 3,000 people with hepatitis B-related diseases that die each year. Most people who carry hepatitis B are unaware that they're infected. For 1 to 6 months, they may have no symptoms at all, and then after this initial period, flu-like symptoms begin to develop. Carriers of hepatitis may sometimes develop jaundice, which is the yellowing of the eye or skin. Hepatitis is a particularly virulent virus, meaning that under ideal conditions it can live outside the body for long periods of time, perhaps days or even weeks. There is a highly effective and safe vaccination against hepatitis B. Hepatitis C is another strain of the hepatitis virus. In many ways, hepatitis C is similar to hepatitis B. For example, both are found in human blood and bodily fluids. Both affect the liver and may lead to liver disease or cancer. Signs and symptoms of exposure to both strains are similar. However, there are numerous important differences. For instance, hepatitis C is much more likely to lead to chronic infection or liver disease. More than half of infected adults will develop chronic infection or liver disease, with many more fatal cases from hepatitis C than hepatitis B, with about 17,000 per year. There's no vaccine for hepatitis C, but hepatitis C has a cure in the form of an antiviral pill that is taken once a day over the course of 8 to 12 weeks. For hepatitis C, a cure is defined as a virus that is not detected in a person's blood 3 months after treatment has been completed. Another important bloodborne pathogen is the human immunodeficiency virus, or HIV, which is the virus that leads to AIDS. HIV and AIDS attacks the body's immune system, leaving its victims susceptible to infections and illnesses that a person with a normal immune system could easily defend against. These conditions may include infection, pneumonia, and brain and central nervous system disorders. HIV can become fatal from HIV infection complications if not treated, and should it contribute to contracting AIDS. At the present time, there is no cure for AIDS. It is proven to be a universally fatal illness. However, most patients survive many years following diagnosis. Many people who carry the virus are unaware they are carriers. Most people don't know right away when they've been infected with HIV, but they may have symptoms within 2 to 6 weeks after they've gotten the virus. There is no vaccine for AIDS. In more recent times, we have become familiar with COVID-19. COVID-19 is a respiratory illness caused by a virus called SARS-CoV-2. Symptoms include cough, shortness of breath, fever, chills, muscle pain, sore throat, or new loss of taste or smell. Humans are the reservoir of concern. Original sources thought to be bats or the mammals. Transmission between people who are in close contact with one another within about 6 feet through respiratory droplets produced when an infected person coughs, sneezes, or is talking. And right now, there is no vaccine currently available. These and other bloodborne illnesses are transferred from one person to another through exposure incidents. In other words, events in which blood and other bodily fluids are exchanged between 2 or more people. In the workplace, this is most common when a person gets another person's blood or other potentially infectious bodily fluids in contact with his or her own mucous membrane, such as eye or mouth. This also occurs when another person's blood, or OPIM, contact broken skin, such as a cut or scratch. This can also occur when a person's skin is punctured by an object which is contaminated with another person's blood or fluids, such as a razor or other type of blade or needle or syringe. Viruses can be transferred off the job as well, most commonly as a result of sexual contact, illicit drug use involving sharing needles. If you have or suspect you may have had a job exposure incident, report it to your supervisor immediately so that arrangements for proper medical follow-up can be made. There are several steps you should take to prevent exposure incidents from occurring. For instance, you must practice universal precautions. In other words, you should assume all potentially infectious bodily fluids are infected and treat them as such. Whenever you're exposed to blood or bodily fluids, you must wear proper personal protective equipment, including safety glasses and gloves of latex, nitrile, or rubber. Also, you must use one-way CPR mask if you provide mouth-to-mouth resuscitation. Use the proper cleanup procedure for cleaning and disinfecting surfaces and equipment, which may be contaminated with human blood or fluids. Whenever possible, the person whose blood or bodily fluids are being cleaned should be the one performing the cleanup to avoid infecting additional people. When this isn't possible, use an approved virucidal cleaner or mix bleach with water, 10 parts water, 1 part bleach. Use long-handled tools for all cleanup. In other words, don't use paper towels, rags, or sponges. Let the surface air dry. Good respiratory hygiene is the best method to prevent transmission through droplets. Cover your mouth and nose with a tissue when coughing or sneezing. Use the nearest waste receptacle to dispose of the tissue after you use it. Perform good hand hygiene, like hand washing with non-antimicrobial soap and water, alcohol-based hand rub, or antiseptic hand wash, after having contact with respiratory secretions and contaminated objects or materials. And you want to avoid touching your eyes, nose, or mouth afterward. For good hand hygiene, hand washing steps will include the use of soap and warm water. Scrub your hands for at least 20 seconds. Use of a nail brush helps. Wash all the surfaces, including between the fingers, under your fingernails, back of your hands and wrists. Rinse well and dry your hands with a paper towel. To reduce the risk of exposure when handling items with surface pathogen contamination can be reduced significantly by effective and immediate cleanup and by taking appropriate safety precautions. So follow proper procedures and properly use personal protective equipment. When we talk about personal protective equipment, PPE is selected based on the risk at hand. When we use the equipment, we need to read the manufacturer's instructions. We also need to be trained on personal protective equipment. That hands-on training would include how to select the proper piece of equipment, how to put it on, and how to take it off. Also, any CDC guidance and how to use it. We want to make sure we understand how to properly dispose of it, and we need to be able to recognize if it's in need of repair or replacement and tell our supervisor when that's the case. For COVID-19, we want to look at PPE, which might include an N95 or KN95 respirator, or surgical mask, which is FDA approved, or a face shield. For surface protection, we want to make sure we wear gloves, perhaps a gown, safety glasses, shield also, and a barrier. Make sure you understand that per OSHA and NIOSH, a cloth facial covering is not considered personal protective equipment. For bloodborne pathogens, the PPE will be similar, including an N95 or KN95 respirator and a surgical mask, and gloves, gowns, safety glasses, or face shield. Again, a cloth facial covering is not considered PPE. And finally, our best controls are engineering and work practice controls. For example, with COVID-19 and these concerns also related to bloodborne pathogens, work remotely if possible. You want to maintain employee distances, 6 feet or more, in the case of COVID-19. Barriers if you can't maintain that distance. You want to minimize employee meetings in large numbers, perhaps limited to 10 or more or fewer employees. For bloodborne pathogen exposures from sharp objects, sharps disposal containers should be in place. Good hand hygiene for either bloodborne pathogen or COVID-19 exposures. Good respiratory hygiene and cough etiquette, especially for COVID-19. Make sure you inform management when you're ill or experiencing any of the symptoms. Stay at home if you're sick or have symptoms of the illness. Leave work if you become sick or start to develop symptoms. And finally, you want to screen visitors and employees when they arrive through questionnaires and perhaps taking their temperature. For good housekeeping, establish a written schedule for cleaning and decontamination on a more frequent basis. Clean and disinfect frequently touched surfaces on a routine basis. Clean the equipment between users and limit sharing when possible. If you use disinfectant, make sure it's an EPA N-listed disinfectant. When you pick up broken glass, don't pick it up by hands. Use mechanical means only. And you want to dispose of the sharp objects in a sharp container if it's available. For more information about biohazards, you might consider references like OSHA Federal Government at www.osha.gov. The Minnesota Department of Labor and Industry has good information. The Center for Disease Controls. The Minnesota Department of Health. Minnesota OSHA has a COVID-19 preparedness plan template and instructions. The Minnesota Department of Workers' Compensation has information as well. The U.S. Department of Labor, Occupational Safety and Health Administration has guidance for preparing workplaces for COVID-19. And perhaps California OSHA, where they talk about aerosol transmissible disease models and exposure control plans. Now let's discuss physical agents. Physical agents can cause damage to your body. You can be exposed to these physical agents both on and off the job. Physical agents you may be exposed to include noise, heat, ultraviolet light, and lasers. When working in noisy areas, you may be exposed to noise levels above 85 decibels, especially when working shifts longer than 8 hours. At this level, noise exposure may cause permanent, irreversible hearing loss. This is compounded by the natural age-related hearing loss, which is inevitable regardless of noise exposure. Noise exposures may also reduce your ability to communicate and cause stress and fatigue. Always avoid unnecessary exposures to noise both on and off the job. Hearing protection is recommended in all noisy areas of the plant, but may be required when noise levels exceed 90 decibels. Always be sure to wear your hearing protection correctly as directed by the manufacturer. Here we have a diagram of the ear. Remember that noise is pressure, sound pressure. Sound pressure enters into our ear canal, up against our eardrum as we know it, and from there is transmitted through that pressure into the cochlea. Inside this cochlea are a bunch of tiny hairs. What happens with sound pressure is eventually those hairs are beaten down, much like grass in a lawn after you walk through it on a path. After time, those blades, or in this case those fibers of hair, will not recover and stand back up again, and thus become permanent damage. Depending on your specific job assignment and the associated exposure to noise, you may be required to have periodic audiograms or hearing tests. These tests are designed to measure and monitor your hearing throughout the course of your employment with our company. These tests are brief, painless, and free of charge. If these tests reveal significant changes to your hearing, you will be notified in writing. However, even if your results are normal, your results will be provided to you at your request for you to review and photocopy if you wish. Ask your supervisor if you'd like to request a copy of your results. When we are required to wear hearing protection, we have a couple of different types to choose from. Here we have ear plugs. They're typically meant to be worn 1 or 2 times and then disposed of. And then here we have ear protection that is mounted on headbands. This type is meant to be like earplugs. They're placed into the ears. They're usually good for a few wearings. And here we have ear muffs. These are actually meant to be on the outside of our ears and do not have internal plugs, and they provide pretty good protection as well. Each of these have their own noise protection rating, which is printed on the side of the box or the package that the hearing device comes from. Heat stress. Our employees may be exposed to varying levels of heat stress. Heat stress is created when employees work in varying combinations of heat, high humidity, lack of ventilation, or heavy workloads. These factors may arise as a result of working outdoors, working near heat-producing equipment, or working indoors in non-air-conditioned areas. When employees are exposed to heat stress, they may develop heat-related illnesses, or HRIs. These conditions may include heat cramps, heat rash, heat exhaustion, or heat stroke. People who are especially susceptible to these conditions are the elderly, people in poor health, people who may be overweight or in generally poor physical condition, or those who have had similar conditions in the past. When working in environments where heat stress may develop, you should increase your fluid intake dramatically, consuming 4 to 8 times your normal fluid intake. Remember that beverages such as soft drinks and coffee have no value in hydration and actually promote dehydration. Alcoholic beverages have the same effect. Only water and sports drinks should be used for the purposes of hydration. When feasible, you should take more frequent breaks in the cool area. Allow yourself time to acclimate to heat a little at a time over a course of a few days. Choose your clothing carefully. Wear loose-fitting clothing made of natural, lightweight, light-colored fabrics, and avoid wearing hats. Of all heat-related illness, the most serious is heat stroke. Heat stroke occurs when a person's body is at or near total dehydration. At this point, the body's core temperature will climb quickly to life-threatening levels. A person with heat stroke will have symptoms which may include dizziness, intense nausea and vomiting, disorientation, and extreme fatigue. They may be sweating profusely, or sweating may stop altogether due to total dehydration. A person with heat stroke will usually not recognize their own symptoms, so it's important that coworkers monitor each other. Treat heat stroke by immediately removing the person from the source of the heat. Cool the person's body by bringing him or her to a cool area and placing cool wet towels on the head, in the armpits, and on the groin. Heat stroke is a life and death medical emergency. Call 911 at once, even if the person begins to feel better. Ultraviolet or UV light is an invisible type of light radiation. The most common source of UV light is the sun, but it can also be produced by certain types of welding and artificial light used for various scientific and manufacturing purposes. Overexposure to UV light can cause temporary irritation or burns to the skin and eyes similar to sunburn. It may also cause premature aging of the skin, or in rare cases, skin cancer. When working outdoors, protect your eyes from the sun by wearing sunglasses, and protect your skin by using sunblock with a high SPF or by wearing clothing that blocks the UV rays. When working around artificial UV light sources, always be sure that guards, shields, welding curtains, and other barriers are in use to block the UV rays from you and others in the area. Remember that equipment that creates UV radiation is typically very hot, so keep combustible materials and flammable liquids away. Welding that produces UV radiation will require special shaded eye protection. A minimum shade filter number will be required based on the circumstances. In the workplace, you may also come across lasers. They're used in several applications in manufacturing and construction. Remember that lasers, or the actual laser array itself, is invisible, and in that state it's an unshielded light radiation. When exposed to this in the eyes, it can cause temporary irritation or burn to the eyes, but also continued exposure can eventually cause permanent damage. We want to remember too that laser sources can also be heat generation and creating exposures to burns. Harmful substances include gases, liquids, or solids that you may work with and can be harmful to your health. A short list of some of the substances you may work with include corrosives, solvents, airborne metals and dusts, nuisance dusts, cleaning and sanitizing chemicals, epoxies, and oils and lubricants. This is only a partial list of harmful substances that you may be exposed to. Please ask your supervisor for a complete list and discuss any other substances not mentioned herein. Also discuss the hazards associated with any of those other substances you may be exposed to with your supervisor. Corrosive is a term used to describe chemicals which have very high or very low pH values. Chemicals which have low pH values are known as acids, and chemicals with high pH values are known as alkalis or bases. Corrosives are found in a variety of forms, including gases or powders, but most commonly are found in liquid form. Common types of corrosives include electrolyte, found in lead-acid batteries, various types of cleaning and janitorial products, water treatment chemicals, catalysts and multi-part epoxies, ammonia, bleach, chlorine, and various types of metal cleaners or other metal treatments. Breathing corrosive mists, vapors, or gases will cause mild irritation to severe burns to the respiratory system. Depending on conditions and the particular chemical at hand, corrosives are also extremely hazardous to other tissues and will cause severe burns to the skin, especially the eyes. Most corrosives will react violently to other types of chemicals. For instance, you should never mix an acid with a base, or mix any acid with any chemical containing chlorine, like bleach. While diluting corrosives with water, the chemical should always be added to the water, rather than adding water to the chemical. Corrosives should only be mixed with other chemicals as directed by the manufacturer. Since corrosives will react violently to most metals, only containers approved for corrosives should be used. When working with any type of corrosive, it is important to prevent any skin or especially eye contact. You must wear special chemical-resistant gloves and splash goggles when handling any chemical which is marked as a corrosive. Other protective equipment may be required based on the type of work and chemical at hand. Never use these products where there is insufficient ventilation or where mist, gases, or vapors could be permitted to build up. Corrosives may only be handled where you have immediate access to an emergency eye wash or shower. If you get any corrosive on your skin or in your eyes, flush the affected area with plenty of running water for at least 15 minutes and seek medical attention at once, remembering that burns from alkaline and other basic materials may not be noticeable for a few hours after the exposure. Solvents. Solvents are chemicals which dissolve or break down other types of chemicals. Most commonly, solvents are found in various cleaners and degreasers, paints and finishes, and inks. Solvents are also frequently used as a propellant in aerosols. While there are numerous types of specific solvents, nearly all are similar in regards to hazards. For example, all solvents may cause a temporary irritation of the skin, known as dermatitis. This is usually marked by a temporary redness, dryness, and cracking of the skin where exposure occurs. Breathing excessive levels of solvent vapors will cause nausea, dizziness, confusion, tightness in the chest, and sluggishness. Long-term overexposure to unsafe levels of solvents may damage the central nervous system, liver, kidneys, blood, or other organs. Intentional overexposure to the solvents found in products such as glue and paint can be instantly fatal. In addition to the general health hazards of solvents we just reviewed, there are some solvents which pose greater health hazards. For example, a limited number of solvents are also classified by OSHA as carcinogenic or cancer-causing. Examples of these carcinogenic solvents include, but are not limited to, benzene, methylethylene chloride, formaldehyde, trichloroethylene, and perchloroethylene. Due to their health hazards, these chemicals are used in a limited number of products. In addition to the health hazards, solvents also pose serious risk related to flammability. Most solvents have extremely high vapor pressures, which means they evaporate much more quickly than other liquids. This process creates flammable vapors which can easily ignite. It's important to store and dispense solvents using containers that are approved for this type of use. Significant quantities of solvents may not be stored in unapproved containers such as glass jars, plastic pails, and so forth. When not in use, all solvents should be stored in approved fireproof cabinets or storage rooms. Solvents may never be used or stored in areas where open flame or spark-producing work is performed, and no smoking is permitted in these areas. Another important type of situation to avoid when working with any type of flammable liquid is static electricity. When liquids are stored in containers, their movement within the container creates a slight electrical charge. Other containers which are filled from the original container may have a different charge, and if the two containers make contact, a spark is created. This spark may be sufficient to ignite the flammable vapors, causing an explosion. Therefore, all such containers must be electrical grounded while in storage, and prior to filling one container from another, the two must be electrically connected using bonding cables. This neutralizes electrical charges so a spark can't occur. The most important safety rule for solvents is to never use them in areas where ventilation may be inadequate. There must be sufficient ventilation to prevent a buildup of flammable toxic vapors. In most cases, the building's normal air exchanges will be sufficient, but certain types of operations, such as spraying solvents and working with dip tanks, will require additional mechanical ventilation. You should also reduce the risk of skin contact with solvents by wearing the proper personal protective equipment, such as safety goggles and solvent-resistant gloves. Some jobs may require respiratory protection, for example, working in spray booths where solvents are applied. However, respirators may only be worn by employees with special training and medical testing. Nuisance dust is any type of dust which, for the most part, free of significant health hazards, unless employees are exposed to unsafe levels for prolonged periods. Dust may cause skin irritation and dryness and may be mildly irritating to the eyes and respiratory tract. Avoid any unnecessary exposure to nuisance dust. Safety glasses or goggles and/or dust masks are recommended and may be required depending on the type of work. If ventilation is provided, be sure it's working properly. Wash hands and any exposed skin frequently when working with nuisance dusts, especially before eating, drinking, or smoking, applying lip balm or cosmetics. It's also important to remember that all dust may form explosive mixtures in the air. Avoid exposing heavy airborne concentrations of dust to any type of open flame or ignition source. Cleaning and sanitizing products are chemicals which are used to clean or disinfect work surfaces and objects such as tools, equipment, and fixtures throughout the workplace. These may include janitorial products such as glass cleaners, toilet bowl cleaners, degreasers, bleach, and other such chemicals. They come in a variety of forms, including liquids, sprays, aerosols, powders, and granules. Nearly all of these products will cause significant irritation to the skin, eyes, and respiratory tract. Some may be corrosive, meaning they will cause serious permanent burns to the same parts of the body. Products that contain chemicals such as ammonia, chlorine, or any other type of acid will also be dangerously reactive and may form deadly byproducts when mixed together. Never use these chemicals with any other chemicals except as directed by the manufacturer. Some of these products may also be extremely flammable, including products that are used in aerosol form, and liquids that contain flammable components such as alcohol. Never store, dispense, use, or discard these products around open flame, spark-producing processes, or intense heat. Never burn or crush containers that have contained flammables. Always use appropriate eye protection and gloves when working with these chemicals, and be sure to use them only in well-ventilated areas. Epoxies. Epoxies are heavy-duty glues and sealants. They come in two parts, a resin and a hardener, and when you mix them together, they cure to create an extremely strong bond. These can contain very toxic chemicals. The catalysts may be irritating or corrosive to the skin, eyes, and respiratory tract. They can also contain isocyanates or amines, which can cause allergic reactions to skin and respiratory system. Extremely serious or fatal exposures can occur, and these exposures and harmful effects can develop slowly over a period of time. The thing about solvents in the epoxy mixes is that they can evaporate quickly. They're easily inhaled and absorbed through the skin, and can affect the kidneys, livers, blood, skin, or eyes, the central nervous system, and can act as a depressant. Epoxies may contain cancer-causing ingredients like crystalline silica, methylene chloride, formaldehyde, benzene, or others. Also flammable, so we never want to use, store, dispense, or discard of them near open flames, sparks, or intense heat. When using epoxies, a respirator may be required, but remember, with respirators there needs to be training and medical evaluations and a fit test. If you have a skin rash or irritation, you may have been overexposed. Also difficulty in breathing or swelling of the lips, throat, face, or tongue. If they should experience these conditions, stop what you're doing and remove yourself into an area of fresh air. Report it to the supervisor, and then don't resume working with epoxies until you see a physician. Oils and lubricants are chemicals which reduce friction in moving parts. They may be in the form of sprays, liquids, pastes, or grease. Skin contact with these products can cause mild irritation. Oil can clog the skin pores and cause acne-like conditions. Waste oils may become contaminated with bacteria and cause foul odors in decompositional products. Oils can be combustible, so don't use, store, dispense, or discard of them around open flames or spark-producing work or intense heat. Carbon monoxide is odorless, invisible, asphyxiating flammable gas. It's often confused with carbon dioxide. This can form from incomplete combustion of any kind of gas, whether natural gas or motor vehicle fuel. The permissible exposure limit for carbon monoxide is 35 parts per million. With products that can produce general carbon monoxide, we may see labeling pictograms, such as the skull and crossbones, the flammable container, the compressed gas, and the health hazard pictograms. Carbon monoxide exposure can occur from inhalation and also contact if it's in a liquid form. It'll reduce red blood cells' ability to convey oxygen. Low-level exposure can cause headaches, fatigue, and nausea. Severe exposure can lead to loss of consciousness and ultimately death. But nearly all effects are reversible if it's caught in time. There's little potential for reactivity. And there is a flammability range for carbon monoxide, which is between 12.5 and 74%. Compressed gases can become an inhalation hazard. Some types, like nitrogen, can become simple asphyxiants. Other types, like compressed air, really don't have any physical hazards to them, but it is plentiful around the plant, whether in compressed gas cylinders or in air tanks and air nozzles and piping throughout the facility. We find compressed gases in welding areas and maintenance areas, primarily oxygen and acetylene. Remember that oxygen will accelerate combustion, and acetylene is explosive. Now, just a couple of reminders about personal protective equipment. Remember that PPE is selected based on the risk at hand. If it's eye exposures, we're looking at eye protection. If it's exposures to cuts and abrasions in our hands, perhaps we're looking at gloves. If it's inhalation hazards, we're looking at respirators. All types of personal protective equipment are going to require some training, so you understand how to use them, how to take them on and off, how to maintain them, and if necessary, how to dispose of them. Also considered part of the personal protective equipment is clothing that we wear for the job. We either need to wear insulated clothing in heat environments or lighter clothing in hot or humid environments that we may work in. If you have personal protective equipment that's in need of repair or replacement, make sure that you tell your supervisor. So that concludes our hazard communication right to know training for today. If you have any questions, comments, or concerns, make sure you tell your supervisor. They can also contact Integrated Loss Control if we can answer your questions for you. We appreciate your participation in the training, so be safe.